In this video, we are going to learn about what are called the principal values of our trig functions. We're only going to focus on sine, cosine, and tangent. We are not going to do the reciprocal functions. All right, let's start off with sine. If you look at the graph I have drawn for you here, is the function of sine 1 to 1? Think about what we did in our last video. Is this graph 1 to 1? Well, you can see that it's not, because if I draw a horizontal line, do you see how it crosses that same y value over and over and over again? And in fact, sine repeats forever in both directions, so that would have infinitely many times when it crosses that particular y value. So what does that mean for the inverse? Well, if you remember from our last video, functions that are not 1 to 1 are not invertible. That means that their inverse is not a function. So what we're going to do is we are going to restrict the domain. I want to force this to have a inverse that is a function. So I'm going to make it a 1 to 1 function. So what we'll do is we will restrict our domain so that I have one positive quadrant and one negative quadrant. So the way we're going to restrict that is right here. I'm going to have one positive quadrant and one negative quadrant. So you can see that if you remember how we went and unfolded the unit circle, this is quadrant 1 right here. And going backwards, I've gone down into quadrant 4. So when I write my restricted domain for sine, that restriction is from negative pi over 2 to positive pi over 2, and it includes both of those values. If I wanted to write it in degrees, that would be from negative 90 to positive 90. Normally we do our restricted domains in radians, but if you need to think about it in degrees, that's okay too. So if I had a question like sine of 1/2, you can see that in my regular sine function, I would have multiple places where sine was positive. If I restricted it from 0 to 2 pi, which is what we've been doing in class, or 0 to 360, if you want to think about it in degrees, we would have an answer in the first quadrant and also in the second quadrant. That's how I know this is not a function, because my one x value of 1/2 would map to two different y values, one in the first quadrant, one in the second quadrant. But now with my restriction, if I ask for the inverse sine of 1/2, I'm only going to get one value because I only have one positive quadrant and one negative quadrant. So my inverse in this case is going to be a function. All right, let's practice with that. Let's do inverse sine of 1/2. Now notice right here that this has changed from being a lowercase s to an uppercase s. When we do the restricted domains, when we do those that are 1 to 1, we always use a capital letter. So this tells me I'm going to use my principal values instead of the values from, say, 0 to 360 or negative 360 to 360. You could actually restrict that any way you want to. But when I put that capital S on there, I'm forcing the restriction to be this, negative pi over 2 to pi over 2, or negative 90 to positive 90. Okay, so sine of 1/2. Well, I know I'm only going to have one answer, and it's going to be a first quadrant answer because that's where my values are positive in the restricted domain. So the question is, which triangle am I going to look at? Sine is opposite over hypotenuse, so which angle has an opposite side of 1 and a hypotenuse of 2? All right, the triangle I'm going to look at is this one, my 30, 60, 90 triangle. So here's 1. What is the angle that is opposite 1? There it is right there. It's 30. So my answer to this, if I were answering in degrees, would be 30 degrees, and I would just write that one angle because in my restricted domain, I just have one answer. Or if I were answering this in radians, I would multiply that by pi over 180, and I would get pi over 6. So either 30 degrees or pi over 6 is the correct answer to this question. There's no reason to give a second angle like we did before because now I have the principal values. I have that capital S. Okay, let's do a negative one. So start off the same way. What angle has a cosine of square root of 3 over 2? Look at your triangles. See if you can figure out which angle has a cosine of square root of 3 over 2. Well, I'm looking at my 30, 60, 90 triangle. Here's the square root of 3 right here. This is opposite over hypotenuse. So square root of 3 is opposite 60 degrees. So my reference angle is going to be 60 degrees. Okay, so now let's consider the fact that it's negative. 60 degrees is here in the first quadrant. I want a fourth quadrant answer, but remember how we restricted the domain? Remember we said it had to go from negative 90 to positive 90, or negative pi over 2 to positive pi over 2? So if I go, that should be a square bracket. So if I go around the unit circle to the fourth quadrant and I end up with 300, you see that 300 is not in the domain that I have chosen. I cannot go this way to get to the fourth quadrant. I have to go down into the fourth quadrant. I have to go backwards on the unit circle, which means I'm going to be using my negative angles. So positive 60 degrees in the first quadrant, and now go backwards around the unit circle in the fourth quadrant, that's going to be negative 60 degrees. Or if we did it in radians, negative pi over 3. And again, I know to do that because I see that capital S right there, and that tells me I'm going to use the principal values. Okay, let's try cosine. So I have a larger graph of cosine here just to emphasize the fact that it goes on and on forever, both directions. It doesn't stop at negative 2 pi and positive 2 pi. It just goes on forever in both directions. So if I asked you for the cosine of square root of 2 over 2, how many answers would you give me? Well, just on what I have right here, I'm going to have positive, 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 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10 different solutions to that just in between negative 5 pi and 5 pi. If I extended this out, it could go on infinitely. I have infinitely many solutions to that. So what does that mean for my function? Is my function, is cosine that I have drawn here, a one-to-one function? Nope, it is not. Again, I get multiple answers when I ask this question, so therefore this is not one-to-one. Its inverse is not a function. So let's restrict our domain. All right, I put it down to negative 2 pi to positive 2 pi so we can see it a little bit better. This time we're going to restrict the domain to one positive quadrant and one negative quadrant, just like we did before. And we want it to be as close to 0 as we can. So if I do the first quadrant and the fourth quadrant like I did for sine, do you see that I have positive on this side and positive on this side? That's not going to work. I need a different restriction. So the restriction that we're going to do is here. I'm going to restrict it so that my one positive quadrant is quadrant 1, just like before, but my negative quadrant is going to be quadrant 2. So my restricted domain for my principal values of cosine, 0 to pi, if I want to think about it in radians, which I usually do, or 0 degrees to 180 degrees if I want to think about it in degrees. So I know you guys at this point are more comfortable with degrees, but we're going to get you, by the time you're in calculus, we'll get you to the point where you're comfortable thinking in radians. So there's my restricted domain for cosine. All right, let's practice one. Let's do cosine of square root of 2 over 2. Okay, so you guys look at your triangles, write them down on your paper if you need to. Which one has square root of 2 over 2? All right, the answer to that is going to be the 45, 45, 90 triangle. Remember we said basically on this one you have to think about the fact that we have to unrationalize, turn it back into what it was before, right? Because the hypotenuse is the square root of 2. The adjacent side is not square root of 2. So the angle that has an adjacent side of 1 and a hypotenuse of square root of 2, that's going to be 45. Adjacent side of 1, hypotenuse of square root of 2. If you look at this 45, you get the same thing. Adjacent side of 1, hypotenuse of square root of 2. Okay, so I want the positive answer. Is my positive answer going to be here in the first quadrant, or is my positive answer going to be here in the second quadrant? Well, that's going to be a positive quadrant answer. I'm sorry, a first quadrant answer for that positive angle. And in the first quadrant, the reference angle is the angle. So in degrees, that would be 45 degrees. In radians, that would be pi over 4. And you can multiply 45 times pi over 180 if you need to change it into radians. All right, let's try this one. Cosine of negative 1/2. Okay, look at your triangles. Which angle has a cosine of 1/2? What is my reference angle going to be? All right, I've got the 30, 60, 90 triangle here. Here's 1. Cosine is adjacent over hypotenuse. So which angle is adjacent to this side 1? Well, that's going to be 60 degrees. So 60 degrees is going to be my reference angle. Is cosine positive in the first? Negative in the first? Or is it negative in the second? Well, it's negative in the second. You can see it below the axis here. But I don't have to go backwards into the second. You can see that I'm starting at 0 and I'm going in a positive direction into the second quadrant. So if I go in a positive direction into the second quadrant, 180 minus 60, 120 degrees, or if I want to do that in radians, the radian value that is the principal value, that is the goes with 60 degrees is pi over 3. And in the second quadrant, that's going to be 2 pi over 3. So the radian value that corresponds to 120 degrees is 2 pi over 3. All right, let's take a look at tangent. Here's tangent. And again, I need to restrict it because it's not 1 to 1. I want to restrict it to 1 positive quadrant and 1 negative quadrant. And I want those to be as close to 0 as possible. So I'm going to pick this part. So the restriction for tangent turns out to be exactly the same as the restriction for sine. In radians, that's going to be negative pi over 2 to pi over 2. Oops. This time it's not included. This time it's a parentheses because there's an asymptote there, right? You remember there's an asymptote right here at pi over 2 and right here, positive pi over 2 and negative pi over 2. So therefore, I cannot have brackets. I have to have parentheses because those are not included. If I want to do that in degrees, negative 90 degrees to positive 90 degrees, but I'm still going to have parentheses. Those are not included because of the asymptotes. Cosine and sine don't have any asymptotes, so their principal value restriction, the endpoints are included. All right, let's try this one. Inverse tangent of 0. So automatically I know I don't have to look for a triangle because I don't have a triangle that has a side of 0. I want to look at one of my quadrantal angles. Or I can think about the graph right here. The graph of tangent is equal to 0 at what value? Well, that's at 0. That's the origin. So it's either 0 degrees or it's 0 radians, whichever you want. You can tell the difference because degrees has to have a unit, and remember radians is unitless. So I don't write anything when it's radians, but I have to write that degree symbol when it's degrees. And just like before, because of the restricted domain, I'm only going to get one answer. Okay, again, I see that capital T, just like I did on the last one, and I'm going to find the angle that has a tangent of -1. So let's do the reference angle first. What angle has a tangent of 1? All right, that's going to be your 45, 45, 90 triangle because tangent is opposite over adjacent, and they have to be the same as each other. So I'm going to have 45 degrees as my reference angle, but I need to go down into the fourth quadrant. So I'm going to start at 0 and I'm going to go backwards 45 degrees, which gives me -45 degrees or negative pi over 4 radians. Either one of those, depending on if you want degrees or radians.